Hey guys, Mr. Martin with the video going over the Unit 3 test. So for number one, we have to show that dy over dx is equal to this rational function. So first, we're always going to start out by putting a derivative operator around the original function. That is going to give us 3x squared plus 4y dy over dx equals the derivative of 1 and 0, plus we have to do the product rule, so that's going to be 8y plus 8x dy over dx. Next, we need to group the dy over dx's. So say we move the 4y dy over dx over here and the 8y over here. That will give us 3x squared minus 8y equals 8x dy over dx minus 4y dy over dx. And we can factor that out, the dy over dx out. We get 3x squared minus 8y equals dy over dx times 8x minus 4y. And the final step is going to be to divide so that we actually get that expression. So we get 3x squared minus 8y divided by 8x minus 4y equals dy over dx. For part B, we need to find the equation of the tangent line at the point 1, 4. So first we need dy over the dx of 1, 4, which is going to equal 3 times 1 squared minus 8 times 4 over 8 times 1 minus 4 times 4. So that's 3 minus 32, which is negative 29 over 8 minus 16, which is negative 8. So we get 29 over 8. And we already know the point is 1, 4. So we have y minus 4 equals 29 over 8 times x minus 1. For part C, we have to find the derivative, second derivative, and evaluate it at the point 1, 0. So now recall that we started out with dy over dx is equal to 3x squared minus 8y over 8x minus 4y. So when we're doing the second derivative, all we're doing is again applying the derivative operator. So on the left side, we're just gonna we'll get some space over here. We'll say we get d2y over dx squared is equal to, so now we have to do the quotient rule. So that's going to be the low function 8x minus 4y times the derivative of the top, which is 6x minus 8 dy over dx minus the high function, which is 3x squared minus 8y times the derivative of the bottom, which is 8 minus 4 dy over dx. And all of this is over 8x minus 4y squared. So from here, it is, in my opinion, advantageous to substitute the point 1, 0 into dy over dx here to replace this dy over dx and this dy over dx. So dy over dx at the point 1, 0 is going to be 3 times 1, which is 3. The y part is going to be 0, so we get just 3 over 8. And so when we replace the 3/8, I would also put 1 and 0 in for x and y. So that's going to give us 8 minus 0 times 6 minus 8 times 3/8 minus x is 1, so 3 minus 0 times 8 minus 4 times 3/8. And all of this is over 8 minus 0 squared, so over 64. And that's going to simplify to be 8 times, so 8 times 3/8 is -3. 6 minus 3 is 3. So it's going to be 8 times 3, which is 24. We'll just put a 24 here. Minus 3 times, so this is 8 minus, what's that, 12 over 8, which is 3/2. So 12 over 8 is equal to 3/2. This part is, so 8 minus 3/2 is, that's the same as 16 over 2, so that's 13 over 2. So we end up with 3 times 13 over 2 all over 64. So this equals 24 minus 39/2 over 64, which that's 48 over 2 minus 39 over 2. So that's 9/2 over 64, which is 9 over 128. For number 2, we need to find the first derivative for f of x, which is going to require that we do the product rule. So we get f prime of x is equal to, we'll say it's the first function multiplied by the derivative of the second function, which is 3e to the 3x. Because for an exponential function, the derivative of the exponential function is the derivative of the exponent times the exponent. So -x times 3e to the 3x plus the second function, which is e to the 3x plus 1 multiplied by the derivative of -x, which is -1. So if we simplify, we get -3x e to the 3x minus e to the 3x minus 1. For part B, we need to find g prime of 1 if g is equal to the ln of f of x. So since g of x equals the ln of f of x, g prime of x is equal to f prime of x over f of x, because that's the derivative of a logarithm. But from the previous step, we know that f prime of x is -3x e to the 3x minus e to the 3x minus 1. And so divided by the original, which is -x times e to the 3x plus 1. That's our derivative. And so then g prime of 1 is equal to, that's going to be -3 e cubed minus e cubed. So -4 e cubed minus 1 over -1 times e cubed plus 1. So we'll just say -e cubed minus 1. Now again, all we did was this. I'm going to put at 1, we did -3 times 1 e to the 3 times 1 minus e to the 3 times 1 minus 1 over -1 times e to the 3 times 1 plus 1, which all of this simplifies to give us this answer. For number 3, we need to show that dy over dx is cosecant y secant y. So in doing this, we put a derivative operator. We'll put it on this side just because we have room. So that's going to give us 2 minus, so sine squared y is the same as sine y squared. It's the equivalent of that. And so we do the chain rule. So we're going to have 2 sine y to the first power times the derivative of sine y, which is cosine y, and then multiply by the derivative of the angle, which is going to give us dy over dx. That equals 0. So in the next step, we need to add all of this to the right. So we get 2 equals 2 sine y cosine y dy over dx. And we want to isolate the dy over dx. So we get 2 over 2 sine y cosine y equals dy over dx. And the 2's cancel to give us a 1 over sine y cosine y, which is just cosecant y secant y equals dy over dx. For part B, we need to find the equation of the tangent line when y equals pi over 4. So first, let's find x because we need the point. So we're going to have 2x minus the sine of pi over 4 squared equals 1. Well, the sine of pi over 4 is square root 2 over 2. So square root 2 over 2 squared is 2 over 4, which is 1/2. So we have 2x minus 1/2 equals 1, which is 2x equals 3/2. And so x equals 3/4. So the point that we have is 3/4 and pi over 4. And then for the slope, we need dy over dx at the point 3/4 pi over 4. But since we know the derivative is just cosecant y secant y, that's going to be cosecant pi over 4 secant pi over 4, which is square root 2 times the square root of 2, which equals 2. So